right, today we're going to look at section 7.2, which is the law of sines. Now, up until this point, we have only solved triangles that are right triangles. So let's go back and review how to solve right triangles. To solve for a missing side of a right triangle, first thing we can use is the Pythagorean theorem. A squared plus b squared equals c squared. That's if we're missing a side. The second way we can solve for a missing side is our special right triangle. So we've got a 45, 45, 90, which is 1, 1 square root of 2. Or we have a 30, 60, 90, which is 1 square root of 3 and 2. Or we can use SOHCAHTOA to solve for those missing sides. Opposite of our hypotenuse, adjacent of our hypotenuse, opposite over adjacent. To solve for a missing angle, we can use any inverse trig function, depending on what we start with. Or we can just subtract from 90 if we're already given one of those two angles already. So that's what we've already covered right here, how to solve right triangles. Now, what if the triangle happens to not be a right triangle? That, in the case, goes to solving any triangle. And we can do two things. We can use the law of sines, which is what we're going to talk about today, or we can use the law of cosines. So let's look at these cases in which we use the law of sines versus the law of cosines. Now, back in geometry, you talked about triangle congruence statements, and they look like letters combined together. So this first one is AAS. This means angle, angle, side. So this is angle, right back up against another angle, and then the side it has. The next one is angle, side angle. This is an angle with a side and then another angle, side angle. The last one for the law of sines is side, side angle. Now notice this one has a star beside it. This one's going to be a little bit more harder for us. If you read it backwards, back in geometry, you called this hypotenuse leg. So right here, just be careful once we get to this third case right here. Now, using the law of cosines falls in these two categories. We'll see this a little bit later. Side, 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 or side, angle, side. Now, just looking at the law of sines first. Now, notice that this is not a right triangle. Other things I need to notice is I have 3 angles inside and 3 sides on the outside. Now, very important here. This angle right here is alpha. Across from alpha is always side A. This angle up here is beta. Across from beta is always side B. This angle right here is gamma. Across from gamma is always side C. So it doesn't matter where I put these sides or these angles, but these two, and these two must always match up. So if I have alpha sitting up here at the top, then A's got to be right here. If I have beta right here, then B's got to be across from it. So it's very important on where we place these angles and these sides, because this is what our law of sines says. It says the sine of alpha, so the sine of the angle, over A, the side that's across from it, equals, we're setting up proportions here, the sine of beta across from the side across from it, which is B, equals the sine of gamma, which is my third angle, across from the side that's across from it, which is C. So it's basically just 3 proportions. If we can have proportions, then all we have to do here is just cross multiply in order to solve for either my angles or my sides. Now, in each of our problems that we get into in a second, our angles we're going to round to the nearest whole number, and our sides we're going to round to the nearest tenth, so 1 decimal place. Now, let's dig a little bit closer into what these actual 3 cases look like if I were to see it on a triangle. So first, let's look at the first case. Angle, angle, side. So here's an angle, followed by another angle, and the side attached to that last angle that I have. So angle, angle, side. Case 2 looks very similar to case 1 because I still have 2 angles on one side, 2 angles on one side. But it's determined by the placement of the side that changes these 2 things up. So here I got angle, side, angle. So angle, side in between, and then angle. Notice that I still have the same 2 angles marked in both of these figures, but it depends on the placement of this S on which one of these 2 cases it is. Here the side comes after the 2 angles. Here the side is between, or we call this the included side, between these 2 angles. So there's my first 2 cases, basically if I'm given 2 angles. My third case, a little bit different, is side, side angle. So here I'm given 2 sides followed by an angle at the end. So here's side, side, angle. Reading it this way, angle, side, side. This is the ambiguous case, hypotenuse leg. We also call this the donkey case. You might hear me talk about that a little bit more, but notice this star beside here. This one right here will have different solutions that come out to be my answers. So what we're fixing to get ready to do is solve these 7 problems right here. The first 4 problems are going to deal with the first 2 cases, angle, angle, side, or angle, side, angle. Problems 5, 6, and 7 are going to deal with my third case, which is side-side angle, which is this ambiguous case. All right, so here we go. Let's start into these 7 problems. So I've already gotten these written out on notebook paper right here, and I've already kind of started number 1, just to kind of give you an idea. All right, everything that my triangle is already given to me in your problems are going to be in black. Everything that's missing is going to be in pink. So I'm trying to solve for every missing angle or missing side based off of these problems. So the first thing I solved for was I tried to determine what kind of triangle it is. This can be very important once we throw in the law of cosines as well. We've got to decide out of these 2 theorems, which one do we use first? So this one is an angle, angle, and a side following right behind. You could also call this side, angle, angle if you wanted to. But we're going to start with angle, angle, side. So this is angle, angle, side, which tells me I need to use the law of sines first. Now, the first thing I solved for was alpha, because I noticed if I'm given 2 angles, the easiest thing to do is to solve for that missing angle. So I did 60 plus 40, which gives me 100, and then 180, because there's 180 degrees in triangle, minus 100 gave me 80 degrees. So this alpha right here is 80, and I like to label my triangle as I go. Now, next thing I do, since this is angle, angle, side, is I'm going to use the law of sines and set up my proportions. So it doesn't matter where you start. You can start at this 40, you can start at 80, you can start at 60, but you got to start with an angle first. If I start at 40, I can say the sine of 40 across from the side that's across from it, which is 4. So setting up my proportions over here, I've got the sine of 40 degrees over 4. All right, equals, I'm looking for my next proportion. So my next proportion I'm going to go with is the 60 and then over c. So this is the sine of 60 over c. My last proportion that I'm going to set up is this 80 that I found. So the sine of 80 over a. Now, there's 2 things that I need to solve for. I got to solve for a and I got to solve for c. So I'm going to cover this one up first in order to solve for c first. Now, for this first one, I'm going to show a lot of work. Then after we get past that, a lot of my work is going to be done just using my calculator. So solving this proportion, first thing I'm going to do is just cross multiply. So I'm going to start with this c. So c sine 40 equals, cross multiplying the other way, 4 sine 60. Now I'm solving for c right here. So to solve for c, I need to divide by the sine of 40. So c equals 4 sine 60 divided by the sine of 40. And this right here is just going to type into my calculator in order for me to find out what c is. All right, so here's my calculator. First thing I need to make sure is that my mode is in degree mode. And my mode is in degree mode, so I can go back to my home screen and just type this in. So this is 4 sine 60 divided by the sine of 40. Now, let me go back here. Remember, my calculator pops open parentheses, so I got to close parentheses at 60, and then I'm going to divide by the sine of 40, and then close that back up. Now, this is a side. We're going to round our sides to the nearest tenth. So if I hit enter here, this gives me out 5.38, and this 8's going to bump this thing up, so C happens to be 5.4. So I'm going to come right here and put C equals 5.4. Now, don't forget, I got to go back and solve for A. So going back to my original problem from the start, I'm going to solve this thing for A. So to solve for A, I'm going to cross this one out, and I'm going to use the first one and the last one. So if I look at this, to solve for this, I'm going to cross multiply once again, and I'm going to get A sine 40. Writing really small so I can make sure I fit it, equals 4 sine 80. All right, to solve for A, I'm just going to divide by the sine of 40. So A here equals 4 sine 80 divided by the sine of 40. And this right here is going to type into my calculator as well. So here we go. 4 sine 80, close up parentheses there, divided by the sine of 40, close up parentheses there. And this right here, rounded to the nearest tenth, gives me 6.1. So A in this problem equals 6.1. And I've solved for this entire triangle using the law of sines. So there's number 1. All right, let's look at number 2. To solve for number 2, first thing I need to figure out is what kind of triangle is this. All right, so here's an angle, and a side is in between these 2 angles. So this is angle, side, angle, which means first thing I need to use is the law of sines. Now, the easiest thing I can do is to solve once again for that missing angle. So right here, beta is the first thing I can solve for. So all I have to do is take 180 and subtract these two angles right here, 35 and 15. So if I do that and subtract, this angle right here comes out to be 130 degrees. So beta in this problem equals 130 degrees. I like to fill that on my problem once I get there. And remember, still things I have to find are A and C. All right, on this problem, I'm going to set my proportions up and kind of talk about in our calculator how we can manage solving this problem. So first thing, let's look to see if I have a side and an angle across from each other that I know both of them. 35 is across from A, don't know A. 15 is across from C, don't know C. But 130 is across from 5, that's where I'm going to begin with. So the sine of 130 divided by 5 equals. Now let's write a proportion with this side A. I'm going to go the sine of 35 over A. And then going with the one for C, it's going to be sine of 15 over C. Always the sine of the angle across from the side. Now to solve for A, I would use this right here. So I would go A sine 130. So A sine 130 equals 5 sine 35. So to solve for A, I would divide this by the sine of 130. So I'm going to go straight to my calculator to do that. So this will be 5 sine 35, close it up, divided by the sine of 130, close it up. So this right here is solving for A. So A right here comes out to be 3.7. So in my problem, A is 3.7. Now remember, I can't use SOHCAHTOA because these are not right triangles to solve for my problem right here. All right, next thing, I'm going to cross this out since I've already found A. And I don't want to use this to be 3.7 because I had to round that. So then I'm going to look at these two. So when I cross multiply, start with my variable I'm missing first. C sine 130 equals, going this way, 5 sine 15. So in my calculator, I'm going to divide this by sine 130. So this gets divided by the sine of 130. So calculator, I've got 5 sine 15 divided by the sine of 130. And this right here rounds to give me 1.7 because this 8 bumps this 6 up. So this right here for C comes out to be 1.7. So then I've solved number 2 for all my missing sides and my missing angles. All right, on 3 and 4, I'm going to try to solve these by just setting up my law of sines and then from there typing it straight into my calculator. Now on 3 and 4, they're a little bit different. And the reason these are different is because my figures are not drawn out. So I like to draw them out first so I can kind of see what's happening. So just draw a normal triangle, doesn't have to be drawn to scale. And one angle, it's 40 degrees, doesn't matter where you put it. So here's 40, remember that's alpha. Another angle is 40 degrees, which means I have an isosceles triangle because my base angles are congruent, and my side C is 2. Now I can't put 2 here because that's alpha. Remember, this should be A. So that's something that I'm missing right here. So I'm going to put A because I'm not really sure what that is. All right, this other one right here was beta. Remember, this was beta, so across from it is B. So I'm also missing B. Now, C was 2. Remember, this is, I'm given alpha, I'm given beta, so this is gamma, and across from gamma is C, which I know here to be 2. Now, looking at this problem, I notice that it is angle, side, angle. So this is angle, side, angle, which means I'm going to use the law of sines to begin this problem. All right, so setting up my proportion, first thing I can do is find this gamma right here. How do I find it? I add these two angles up, or I take 180 and subtract both of these angles right here. But 40 and 40 is 80. 180 minus 80 just gives me 100. So right here, gamma is 100 degrees. I'm going to go ahead and fill that in because I can use that 100 in order to solve my problem. Other things I need to find in this problem are A and B. All right, so let's see what we can do to solve this right here. First thing, I need the angle and the side across from each other that I know. Well, this is the one I know right here, the 100 and the 2. So setting up my proportion looks like this. The sine of 100 over 2 equals, doesn't matter which one you go with next. I'm going to go 40 over A. So this is the sine of 40 over A equals, then I'm going to go sine of 40 over B. Now, remember we talked about before, this is an isosceles triangle right here, which means if this is 40 and this is 40, then A and B should really equal each other. So really whatever I get out for A, B is going to be exactly the same thing. All right, so just looking at this problem first. To solve this problem, the first thing I would do is I would type in my calculator what I know first, 2 sine 140. Because when I go to cross multiply, since this is being multiplied, I would eventually have to divide by the sine of 100. So in my calculator, I'm going to type in 2 sine 40 divided by the sine of 100. So 2 sine 40 divided by the sine of 100. And this right here gives me out 1.3. This 0 does nothing right there. So A in this problem comes out to be 1.3. Now remember we said to solve for beta, I'm doing exactly the same thing. Because right here I would say 2 sine 40 divided by the sine of 100 since it's getting multiplied by B. So you would get exactly the same thing back, 1.3. So I've solved number 3 for all 3 missing parts. All right, let's look at number 4. Last one before we move to that ambiguous case right here. On number 4, first thing I'm going to do is draw this thing out since my triangle's not given to me. Doesn't matter how you draw it. Alpha's 40, doesn't matter where it is. So this is 40 across from alpha is A. Well, they give me A to be 10, so I can go ahead and put that across from it too. Beta is 61, doesn't matter where you put beta. I'm going to throw it down here. Across from beta is B. I'm not given B, so that's something that I do not know. So I'm going to put B here. And then the last thing I don't know is gamma, so my other missing angle would be gamma, and across from gamma would be C. So looking at this problem, to identify it, I'm looking at these 3 things that are in purple right here. So this is angle, angle, side. So since this is angle, angle, side, I have to use the law of sines to solve this problem. All right, so first thing, setting up my proportion. I can't set a proportion up until I solve for this angle first. To solve for this angle, I'm just going to take 180, and I'm going to subtract my 2 angles, 40 and 61. So 180 minus 40 minus 61 gives me out 79 degrees. So gamma right here, I'm going to go ahead and write in there, is 79 degrees. So coming over here, gamma is 79 degrees. Other things I need to solve for are B and C. Angles nearest whole degree, sides nearest tenth. So let's set up our proportions in order to solve these things. First thing, let's look to see what we know. We know that this 40 is across from this 10, so let's start there. The sine of 40 all over 10 equals, doesn't matter where you go to next. I'm going to go the sine of 61 over B. And then my last one is going to be the sine of what I just found, gamma, so the sine of 79 all over C. And I'm going to solve for B first. All right, solving this in my calculator. Remember, I'm going to go multiply this way and then multiply this way. So I need to take this right here, what I do not have a variable with first. So 10 sine 61 is going to get divided by the sine of 40 because it was really multiplied by B. So to solve for B, I would have to divide by it. So in my calculator, I'm typing in 10 sine 61 divided by the sine of 40. And that gives me this side to be 13.6 because it doesn't do anything with that. So I just solve for B. So B is 13.6. All right, to solve for C, I'm going to cover this one up and use the first one and the last one right here. And in my calculator, I'm going to type in 10 sine 79, everything that I know right here, and then divided by the sine of 40. So 10 sine 79 divided by the sine of 40. And this side right here is 15.3 because this 7 is going to bump that 2 up to a 3. So this right here becomes 15.3. All right, so there's the first 4 problems in our notes using those first 2 cases, angle, angle, side, and angle, side, angle. Now, let's look at our last 3 problems where we're using that ambiguous case. We call this the donkey case. I'm going to flip over here. And here's my next 3 problems, 5, 6, and 7. All right, so let's first begin with number 5. If I look at number 5, the first thing I notice is it is not drawn out. So the first thing I need to do is take this problem and draw this thing out. All right, the other thing I notice is I'm only given one angle. Whenever I'm drawing a problem out, the side angle, I always want to put my angle in this bottom right-hand corner. So this is alpha. It doesn't matter which one they give me. So that's 40. Now, across from alpha is A. Well, they give me A, which is 3. Next thing I'm going to do is put this other side, which is B, across or right beside this to look like here. Now, since that was B, we got to look at some things that we're missing. Since 2 was B, across from B is going to be beta. So this is alpha, this is beta, so this happens to be gamma, and across from gamma is C. So I'm missing 2 angles and a side, and I cannot use Pythagorean theorem because this is not a right triangle. So I got to go with the law of sines to begin with. Now looking at the law of sines, the first thing I notice is I have a side and an angle, so if you see this right here, across from each other that I know. So when I set up my proportions, that's where I'm going to begin at. So we've got the sine of 40 over 3. Equals, doesn't matter where we begin, but my best option is to find beta over 2 because these right here are both unknowns. So I'm going to go the sine of beta over 2. And I'm solving for an angle. So remember, to solve for an angle, I have to do inverse trig in order to get me there. So first, let's look at cross multiplying here. So I'm going to start with this 3 sine beta. Notice I didn't set that other one up because it's 2 unknowns and it's not going to help me quite yet. So 3 sine beta equals 2 sine 40. Remember, I'm trying to get my trig function all by itself. So I want sine beta to be by itself, so I'm going to divide by 3. So sine beta equals 2 sine 40, all divided by 3. Now, how do we get rid of sine? We do the inverse. Inverse of sine is sine inverse. So in my calculator, I'm going to type in sine inverse of all of this into my calculator. All right, so here we go. Sine inverse of 2 sine 40 divided by 3. Remember, sine inverse open parentheses up, so I got to make sure I close it. And then when I type sine in, it opened parentheses up, so I had to close it around that 42. Now, this is going to be an angle. So we're rounding angles to the nearest whole number. So this angle right here comes out to be 25 degrees because this 3 does nothing to that 5. So in order to solve this problem, first thing I solved for was beta. So I'm going to come right down here and put beta equals what I just found, which was 25 degrees. And I'm going to label my picture. So 25 is going to go here. Now, looking at my triangle, now I've got 2 angles. Since I have 2 angles, easiest thing to do is to find this other angle, which is gamma. Well, to solve for that, all I have to do now is just subtract both of these from 180. So 180 minus what I just found, 25, also what I was given, which is 40, and that's 115 degrees. So now this is 115. Now I have everything except this C, but since I have the angle across from C, now I can just set up my extra law of sine. So I'm going to come up here and say equals the sine of 115 over C. Now to solve this one, I'm going to use these two and do what we did just a little bit ago. So first thing, going with what I know, 3 sine 115, and then I got to divide by the sine of 40. So 3 sine 115, and then that's going to get divided by what I'm multiplying by, which is the sine of 40. And this right here is the side, so we're rounded to the nearest tenth. So this right here, this 2 does nothing to this 2, so that stays 4.2. So that's side C, 4.2. All right, now, that's one problem. On these ambiguous cases, 5, 6, and 7, there's a possibility that we could have more than one triangle. So the next thing I'm going to do is show you how to check for an extra triangle using these problems. All right, so checking for my next triangle, I'm going to draw the same picture out. Angle needs to be in the bottom left-hand corner. Across from 40 was 3. This is what I was given. And this side 2 needs to be right here. Now, let's check to see if we have an extra triangle. First thing we're going to do to see if we have another triangle is to make this triangle isosceles. Now, when I say isosceles, I'm talking about this triangle right here, okay? So, if this side is 3, then this side right here, let me change color so you can see this a little bit better, must also be 3. Isosceles triangle. All right, next thing. Across from 2, I need to know this angle. So if I know this angle, then these 2 angles are congruent to each other because we have an isosceles triangle. So across from 2, here's 2. I found this to be 25 degrees. So across from 2, this is 25. Since this is 25, this little angle right here is also going to be 25 because this is an isosceles triangle. Isosceles triangle, base angles are congruent. So this is 25. Now, since this is 25, I can find this little bitty angle right here because these are supplementary angles. Supplementary angles, linear pair, make a straight line. So I'm going to take 180 and subtract 25, and this angle right here is going to be 155. Now, when we say, do we have 2 triangles, this is the other triangle I'm looking for. Do I have another one right here? Okay. So first thing, let's check is our angles. We got 155 and 40. Well, if I take 155 and add 40, that's going to give me 195. We can't have over 180 degrees in a triangle, so this right here only has one figure. So this right here is not another triangle. So here on problem number 5, I only had one solution to my answers. Now we're going to do 2 more of these, and each of these cases are going to come out to look a little bit different. So let's use that in order to do number 6. All right, solving number 6. We've got 2 sides and an angle, so let's draw it out. Remember, angle goes here, so this is 35. That's alpha. I'm given A, which is 6, so it's going to go across from here. They also give me this other side to be 8. Other side goes here. So angle and side, you know, across from it, and the other side is going to go straight over here on the left-hand side. Across from B is beta. So beta is what I don't know, which means this is gamma and this is C. Now, since this is side-side angle, to solve this problem, I got to use the law of sines, and this is where I'm going to start right here. So I'm going to set this up. The sine of 35 over 6 equals, let's go with beta again, the sine of beta over 8. And I'm going to do a lot of this in my calculator here. All right, I'm solving for sine of beta. So this is what I'm going to type into my calculator first. This is what I know. Then I got to divide by 6, and I have to take the inverse. So the first thing I'm going to do is inverse what I know, which is 8 sine 35. That gets divided by 6. Make sure you close it up again. And this right here comes out to be 50 degrees. Now, why 50? Because this 8's going to bump this thing up. So I just found beta. So coming over here to get to my answers, beta equals 50 degrees. And I'm going to label my problem 50. Now, since I have beta to be 50, this is 35, this is 50. I can take those both away from 180. And that's going to give me this angle to be 95 degrees. So this angle is 95. So then I just found gamma right there. So gamma is 95 degrees. Last thing I have to find is C. To find C, I'm going to come over here and set up my other proportion, sine of 95 over C. Not using this one. I'm going to solve for C by cross multiplying here and dividing here. So 6 sine 95, this is what I'm typing into my calculator, divided by the sine of 35 is going to give me this side, which is going to be 10.4. So that's the other side that I solved for, 10.4. All right, now that's one triangle. Next thing we have to do is make sure we don't have another triangle. So I got to draw my triangle out again. Angle goes in the bottom left, 35. Across from it is A, so that's 6. Remember, my other side always goes right here. All right, so I do it just like I did before. All right, next thing. I'm going to make my isosceles triangle. If this is 6, this is 6. Next thing I do is find these two angles based off of what I got from my original problem. So this is 8. Across from 8, which was B, is going to be beta. So that was 50. So this is 50, which means this is 50. Next thing I have to do is find my linear pair right there. So I'm going to take 180, subtract 50, and that angle is going to come out to be 130 degrees. Now, this is the triangle I'm looking at right here. So if I take 35 and 130 and add those together, that just gives me out 165. So I have enough to make another triangle. So if I take 180 and subtract 165, this angle up here is going to be 15 degrees. So I have another answer. All right, so let's look at what this answer could actually be. This is the triangle I'm looking at right here, okay? Across from 8 was B. So this new angle for beta is going to be 130. So beta could be 50 and beta could be 130. This angle up here was gamma. Remember, top angle was gamma right here. So my gamma before was 95. Now it's 15. So this could be 15 degrees. Now the only thing I have left to find is what this right here is going to be in order to be for my C. So I need to set a little proportion up using the law of sines in order to solve for that. All right, so let's go with 35 and 6, just like we had before. So we got the sine of 35 over 6 equals the sine of 15 over what I don't know. C, we'll call it. All right, so solving for side C. In my calc, I'm going to type in 6 sine 15 and then divide that by the sine of 35. And that's going to give me my missing side, which in this case gives me out 2.7. So 2.7 would be the other side. So I'm going to say and 2.7. So on problem number 6, we had 2 triangles. Problem number 5 only had 1. Problem number 6 had 2. Now, let's look to see what happens on problem number 7. Now, looking at problem number 7, I've got side, side, angle, or angle, side, side. I don't like the way this one's drawn. So the first thing I'm going to do is redraw this how we talked about drawing 5 and 6. Angle's 50, but I need that to be in the bottom left-hand corner. Across from 50 is 1, so across from my 50 also needs to be 1. The other side needs to go right here that I'm given. The other side I'm given is 2. And let's put things that we know. Across from 2 was alpha, so across from 2 is still going to be alpha. Right here has to be my other side, which in this problem is beta. So beta's up here and B's down here. So I'm going to set a proportion up using this first. So we've got the sine of 50 over 1 equals, got to find alpha first, sine of alpha over 2. No need for me to do beta and B because those are both missing. Now in my calculator, I'm solving for alpha, which means I gotta do sine inverse first. So I'm gonna type in sine inverse of 2 sine 50 and then divide that by 1. Now let's watch what happens here. Sine inverse of 2 sine 50, and then that gets divided by 1. All right, this is what I get, error, domain. Basically, you can't take the inverse if it's not within that restriction for sine inverse, which before we talked about those inverse functions had to be between negative pi over 2 and positive pi over 2, negative 90, positive 90. So that's not going to work right here. So this right here, I have no angle for alpha, so alpha does not exist. If alpha does not exist, basically right here, I do not have a triangle. So this right here, on problem number 7, my answer is does not exist. You don't even have a triangle. So with this ambiguous case, it can get crazy. You can have no triangles, you can have one triangle, or you can have two triangles. That's why we gotta be careful on how we redraw these figures out in order to get our solutions. So that's the law of sines. Angle and side always across from each other.